Well, let's have a look at this wonderful formula, the perpendicular distance formula. The reason it's so important is because whenever they say find the distance from a point to a line, now obviously you could draw lines in all sorts of direction and come up with all sorts of distances. So when they say find the distance from a point to a line, they're talking about what's the shortest distance, and the shortest distance is always the perpendicular distance. Okay. So there's a point, some random point, which I'll call x1, y1, and there's some random line. Now, for this formula, we need the equation of the line to be in general form. So the perpendicular distance is what we're trying to find. Now, I won't go and derive this formula, but basically it comes from creating Pythagoras' theorem. So again, drawing up a right-angled triangle, and you end up with this wonderful formula here. So you can see there's the Pythagoras bit on the bottom, the square root of a squared plus b squared. On the top is basically it's the absolute value of the equation of the line, but we substitute in the coordinates of the point. So it's a rather easy one to remember. So on the top of the fraction has to be absolute value, because depending on which side of the line you are, you'll come up with either a positive or a negative number. So because it's a length, we want a positive number, so we make it absolute value. So absolute value, the equation of the line, and substitute the points in. And then on the bottom, the square root of the coefficients of x and y. So let's do an example here. And you might be thinking, well, this is a rather odd example. Find the equation of a circle, and we're looking at perpendicular distance formula. There's a theorem in circle geometry you may or may not remember, that the radius is always perpendicular to the tangent. So effectively, what we're saying here is, what's the radius of this circle? Because if we know the centre and we know the radius, we can write down the equation of the circle. So here's my circle. The centre is 1, 4. There's the tangent. Has equation 3x minus 4y minus 12 equals 0. The radius is perpendicular to the tangent. So when we look at that diagram, we can see, oh yes, they're asking us what is the perpendicular distance of the centre to the tangent. So we just plug it into our formula. So there we go. On the top, absolute value, the equation of the line in general form, but instead of writing x and y, I've written the coordinates of the point, so 1, 4. And then on the bottom of the fraction, the square root of the coefficients, so 3 squared and 4 squared. Well, I wrote negative 4 squared. Again, it doesn't really matter whether you write 4 or negative 4, because you're about to square it anyway. And that works out to be, oh, how nice, that works out very lovely. 25 on the square root of 25, which of course works out to be 5. So I can now complete this question, because the question says, what's the equation of the circle? Well, I know it's going to be x minus the x value of the centre squared plus y minus the y value of the centre squared will equal the radius squared. So it'll be x minus 1 squared, y minus 4 squared is 25. Now, this is what I briefly just mentioned. If, when you substitute into the general equation, you get different signs for different points, then they must be on opposite sides of the line. Because if you think of your number plane, we know the line is where it's equal to 0. So on one side of the line, because if I had said to you, shade in the inequality where it's greater than 0, you would shade in one side of the line. So every point there, when I substituted in, would give a positive number. But then, if I was to shade the other side, every point there would give me a negative number. Now, I don't know whether I've really seen a question like this before, but I could use that idea if ever I wanted to know whether 2 points were on the same side of the line or were on opposite sides of the line. If I substitute them in, and they're both positive or they're both negative, then I know they're on the same side of the line. If one was positive, one was negative, I know they would be on opposite sides of the line. One day, we're going to come up with a question where that'll be useful. All right, that's enough for today. 5E.